Welcome to today's lecture. We are still on the journey of learning to factorize trinomials, and we are quite deep into the journey now. Today we're going to look at a little bit more of a complex factorization, because the coefficient of the first term is going to be larger than 1, which means when we divide it into parentheses it's not quite as simple. But I will show you how it is done. It can be done. Okay, so if you're not already following me on my channel, you're welcome to press subscribe below and become one of the followers, and you can also catch up on materials which you haven't seen yet, as you've missed the lectures I have from grade 1 all the way to senior school on my channel. Welcome aboard. Right, so today we're going to look at factorizing trinomials where the coefficient of the first term is larger than 1. Okay, it's bigger than 1. So let's look at this one here. We can see the coefficient of the first term is 3. It's larger than 1. It makes life a bit more complex when we have to split it into the two brackets or the two parentheses when we factorize, but it's not so bad. The rule would be that we're first going to find the factors of that and then the factors of that in order to get them to add up to that. So we'll look at two basic ones. We're still following the original rules that we've learned with factorizing, and let's just see 3. The factors of the coefficient of 3, this is a nice easy one because it's a prime number, will only have 2 factors. So this will be easy to factorize. 3 only has 3 and 1, which would be the silent 1 in front of that x. So we're going to put them there as the factors of our first term. And then the factors of 5 are also easy because 5 is also a prime number. So we're going to have 5 and 1. And because we have a positive sign here, it means they're both going to be the same, and that sign there tells us they're both going to be positive. So that was quite easy. And if we check it, we'll see the factors of 5. If we multiply this out, because we have a coefficient of 3 here, we're going to get that's going to be 3x plus 5x, and that will become 8x over there. So let's just look at that. When we eventually multiply this out to become the original trinomial, we can see we factorized it properly, because that would become 3x, that would become 5x, and the two of them would become the 8, which actually is that over there. Okay, let's do one more simple one, and then we'll look at one that's a little bit more complex. We have 4x squared minus 8x minus 5. So we're going to have to factorize this first. That would be 2x and 2x. So those are quite simple to factorize. There isn't a huge range of factors for 4x squared. And then we're going to factorize our 5, which is easy because it is a prime number. So we have a 5 and we have a 1. And then we have a minus sign here, which means that both the signs are going to be the same. And this minus tells us those two signs are going to both be minuses. Okay. Now, we need to check when we multiply that and that we're actually going to get a minus 8x. So let's see, 2x times minus 1 is going to be minus 2x, and then this is going to be minus 10x, and 2x minus 10x is going to give us minus 8. So that's actually going to work out okay. Now, let's look at the next one here. We have a much bigger range of factors for our coefficient here. There's various factors for 10. And there's various factors for 12. So let's go list them first. We're going to have to work this one out the long, winding way. 10's factors will be 1 and 10, 2 and 5. Okay? So we're going to take turns with all of them to work out what's going to be the best solution for factorizing this trinomial. 12's factors are going to be 1 and 12, 2 and 6, 3 and 4. So we have to go through the motions with each of those factors to see which ones will combine to come to 23x. Okay, so let's have a look here. 10x, so we've got that factor combination, 10 and 1, by that factor combination, 1 and 12. And let's see if they're going to work out to 23x in the middle. Okay, so once we've multiplied that and that, are they going to become 23x? Let's have a look. No, because 120x plus x is not 23x. So that solution won't work. We're going to have to look at the next factors. Now we're going to look at still 1 and 10, but by those factors of 12. Okay, and we can see they're not going to work either, because it'll be 60 plus 2, which is not equal to 23. Now we're going to look at still that, but that combination of 12. Okay, so that's 3 and 4. And did they work? No, because 40x plus 3x is not 23x. We're trying to find something that will come to the middle term. So now we have to move. We finished with those factors of 10. We have to move on to those factors of 10. So we're going to go 2 and 5. So here we have 2x and 5x. And we start right at the beginning of the factors of 12 again, 1 and 12. And let's have a look. 24x plus 5x is not 23x, so that's not going to work. So we're going to go now with that combination onto that combination. 2x and 5x and 2 and 6. Are they going to work? 12x plus 10x is not 23x. So now we're going to go on to this combination and that combination. 2x and 5x plus 3 and plus 4. 8x plus 15x is equal to 23. So this is actually the perfect factorization of that trinomial with a coefficient that is greater than 1. Okay, so you've got the idea now. You just list your factors, and then you're going to work through them systematically until you find the correct answer. See you in tomorrow's class.